In this video, I'm going to talk a bit more about classes and methods. And so remember from our previous video that classes are sort of the description or blueprint for objects. And so I used sort of the analogy of a hammer where we have a description of a hammer, which would say it has like a metal head and wooden handle and things like that. And then the methods for it would be, like the things you can do with the hammer. So like pound nails or pry nails or things like that. And then the objects are the instantiations of the class. So we have this class, which would be kind of like the description of a hammer. Then the objects would be sort of the actual objects in the world that uh, instantiate that are described by the class. And so we will talk a bit more about that in this video. And so the first thing to kind of talk about, and I mentioned this a bit in the previous video, but I'm going to be a little bit more explicit about it here, is this main method. And so the main method is, as I said in the previous video, the code has actually executed. And so what you'll find is if you have some code and you don't have a main method, then when you try running the code, nothing will happen. But likewise, if you have more than one main method, then it's going to throw an error and tell you that there are multiple entry points into the code. So you need one and only one main method. And so the method calls all the other methods. So all the other methods in your code that you want to use, they have to be called within the main method. And so kind of sticking with our tools analogy here, so if all the methods are like tools in a workshop, like for instance a hammer, then the main method is sort of like the person in the workshop. So the person is the one who has to do the work, but the person can grab different tools from around the workshop to carry out their task. And so sort of in the pseudo code that would look like this, where we have the main method, which is sort of like the person in the workshop. And then that person can grab these different tools while they are in their workshop. All right, and so one thing you may have noticed, and I didn't really touch on in the previous video, was this static thing here, this static keyword that we are using. And so I already discussed in the previous video what the modifier void means. And so up here, that means there's no return type. So the code is just run, but nothing is sort of output from it. But what does the static mean? And so we will discuss a little bit of static here. So you can make classes, you can make properties, and you can make methods declared as static. And so a static class just cannot be instantiated. So instead, you would use things for properties. You'd use the class name dot whatever the field name is, and then set it equal to the value. And for methods, you use the class name dot method name. So instead of the object name, you actually use the class name because you won't instantiate any objects for it. So you'll just use the class name dot method name there. And so a static method in C# is a method that keeps only one copy of the method at the type level, which is why you use the class name here rather than an object. So it's the method is kept at the type level and not the object level. So the last updated value of the method is shared among all objects of that type. And this, I'm talking in very much abstract here, but I will look at these in a little bit more concretely here in a minute. So that means that all class instances share the exact copy of the method in its data. Fields used in the static method must also be static. I'll show that here in a little bit. Static properties are shared among all instances of objects instantiated from the class. So for instance, if you have the non-static class with the static property num1, and num2 here actually. So we have this public static int num1 and public static int num2. Then we have this non-static method here, public int add method. So you don't actually have to put anything as parameters in it. This will just know that you are talking about this num1, this static num1 here, and this static num2 here. So if you instantiate the class, then the num1 and num2 here, so you can set those equal to numbers like 500 and 100. So we have this where num1 equals 500, num2 equals 100, and we have these three instantiations, but all of them will just use these same numbers from these static fields here. All right, then we can look at this a little bit more concretely. And so for this, so I have quite a bit of code to look at in here. So I actually have it just sort of pre-written out here, and I have most of it commented out, and I will uncomment it as we go here. So I have this up here. So this is a class, a static class that I'm calling my static class. It has these two static properties here and then this static method here. So we can go down here, and so I have the main method right here. So this is the code that will actually be executed. And so right here is where we are looking at that static class with the static properties in the static method. So this my static class here. So we see that we have this num a, I'm setting equal to 7, and this num b equal to 3. So we see that the syntax for that is just the class name dot num a and num b. And so the num a and num b are these two static fields that I have up here. Then we have this int num1, so I'm just making this num1 be equal to the output of this, so it'll just return the sum of the num a and num b, which is why I'm calling it the adder method here. So this int num1 here will just be the sum of those two numbers, and so we see that the syntax for that is the class name dot adder method 1 here. And so this will be the addition of the num a and num b, which is the 7 plus 3. And so then I have this printed out here. And so this up here, so I'll actually re-comment this out since I don't want to look at that yet. So we have these two numbers here, and then we'll see that I'll print this to the console. So when I click on that, we will see that this will print out the sum of those two numbers. So adder method 1 gives us 10, so 7 plus 3 is 10 right there. And I will talk a bit more about like this console.writeLine and what I have going on in here. So one thing to notice too, before, even right at the outset, I have this console.writeLine, which is what prints it to the console. And we see that this is actually a static method. So this console is a built-in class with the built-in method writeLine. And so we see that we're actually using a static method here. So we're just calling this built-in method with its built-in, or this built-in class with this built-in method here, just like we are with this, this class that I made here. All right, so then to look at this this other one here, so I will uncomment this. So I'm just calling this my class 1. So this is a non-static class containing static properties and a static method here. And I will uncomment it out down here where it's actually being used in the in the main method here. So these are static properties and methods. So the thing to kind of notice here, and you may have noticed it in the previous one as well, is that we don't actually have to take an input in on this adder method here, which on this one I'm calling adder method 1, this one's adder method 2. It just knows that this num C here and num D are these static properties here. But then we can actually add a parameter on here. So this is just adding another number here that we can specify down in the main method. So we're doing class 1.numC and class 1.numD, and I'm just setting that equal to 10 and 4. Then we are getting the int num2, so this is just will be the output of it. And so I'm putting a 2 in here. That's the parameter it's taking in. That's this parameter right here that it's taking in. Then I'll just take this numc plus numd plus our input parameter there. And so we will see that this should come out equal to 16 right here when we print it out using this built-in class and method right there. And so we will see that this will give us the 10 for that one and 16 for that one. And this down here is just to show that we can instantiate this since the class is not static. Where what we see up here, so I have this commented out, that this one, because the class is static, we can't instantiate it. So if I uncomment it, we see that this will give us this error. It'll give us this red underline. Then down here it'll tell us we cannot declare a variable of static type. We can't create an instance of the static class. So this cannot be instantiated. So I will re-comment that out. All right, and so then I have another one up here, so I will uncomment this right here. And so this is a non-static class containing static properties, but a non-static method. And so I will uncomment that out down here, so we end up with that. And so we see up here that, like I said, it's a non-static class and it's a non-static method, but we still have these static properties here. So again, we don't have to put those in as parameters into our method here. And since we have a non-static class with a non-static method, that means we have to instantiate this. So I'm instantiating it 3 times. But what we see here is when I set the 2 static properties here, one equal to 500 and one equal to 100, then in all 3 of these instances of the class, they will just take in these same 2 numbers here, since those static properties will be the same for all instances of the class. And so I'm setting it to 500 and 100, so we see that if we run this, we should just get 600 for all 3 of them. So yeah, we see that we have 600 for all 3 of those. And so then here, this will just be a static method here, so I'll uncomment that out. So I actually have to uncomment out this class 3 here. And for that, so I'm going to uncomment this because there's going to be stuff that I do in here that doesn't, or that requires these other things. But I have to uncomment out the method I'll be using too. I'll be talking about this other code in here, which are constructors, in a little bit. So I'll uncomment the rest of this method here. So now we have the method that I'm going to be using with these properties up here. And so again, I'm using a static method here. So The thing to notice is just that we're using the class name then with the multiplier method here, where this is taking in this number 17. So it's just taking in 17 as a parameter and just multiplying it by 10. So that should give us 170. So when I run this, we end up with 170 right there. All right, now I will discuss these constructors here. So I will uncomment, I'll uncomment the first one and just go through these one at a time. So a constructor is just something here that has the same name as a class. So we're using my class 3 here, but now it has two parameters. And so it just takes in this number here and this number here, and it will actually set these two fields here equal to those. And then it will set this field here that I'm calling consum for just constructor sum, set that equal to those two things. So what we can do with that, so this is a constructor and is taking two arguments here, and both of them are integers. So I will actually uncomment out this first constructor here. So I'll uncomment that. And so we see that we're using my class 3. We're creating an object for it, my class 3. But now I put these two integers into here as arguments. Then we are making this int con1, and so we are setting this equal to our object dot consum, and then we will print that out. And so that gives us 11 here. And so that is because we have up here this capital num g being equal to this num g input, and this capital num h being equal to this num h input. And so we see down here we have 6 and 5. So adding those together gives us 11. And so when we use this consum here, that will give us 11. So when we run that, we see that we get 11 from our two argument constructor. All right, and then I will uncomment out this constructor here, which we see is now taking in 3 arguments. And so we have this 2 argument constructor and this 3 argument constructor. They both have this same name, my class 3. But the compiler will know that that they are different constructors because they have a different number of arguments. So for that one, I'm using 3, 4, and 5. And so this one is prod. Constructor product. So it's just the product of num g, num h, and num I, which we are setting equal to our input parameters there, which down here we see is 3, 4, and 5. So it'll take 3 times 4 times 5. And so when we run that, we see we get from that 60. So 3 times 4 times 5 is 60. And so that is our three parameter constructor there. But the other thing we can see with these constructors, so if I uncomment this one out, so this one also takes 3 parameters here, but one of the parameters is, instead of an int type, is this string type. And so the compiler will know that this is a different constructor because it's taking in a different type as one of its arguments. So it has the same class name again as usual, but at least one of the parameters is different, as a different type from this other parameter. And so if we uncomment that out down here, we will see that we now have 3, 4, and then this third parameter here is a string type. And I will talk about what's going on in this here in just a minute. But if we run this, we see that we get as the output we get from the 3 constructor with string. So this one up here is without string. This is with string. And so we are taking the modulus of 3 and 4, and we're outputting it there. And so the thing to that the takeaway from this is that we can build these constructors, and the constructors have the same name as the class that they are in, but they take in arguments here. So they have parameters. So those are static classes, methods, and parameters, and then constructors. So now I'm going to talk about these built-in methods here. And so the one we've been seeing is this console.writeLine, which we see the console here is a built-in class with the built-in method writeLine. And so writeLine here prints to console and then goes down one line. So something you may have noticed is that we use these indexers here in our string. So if we have, for instance, these two values here, we can actually print them inside the string using these curly brackets. So that is actually what I had going on up here for in the main method right here. So I have this output 0 equals 1 and this output 1 equals 23. And so we put these curly brackets in here starting from the index 0 and going to index 1, and then it will output these things after the comma. So you put a comma there, then output 0, that will print out right there, then comma, output 1, that will print out right there. And the other thing to notice is that you can concatenate these things. So we end up, so if we have int integer 1 and int integer 2, we can put this in. So we have the string right here, then you close the string, put a plus integer 1 plus, then we have string is plus integer 2. And the thing you'll notice is that we want these spaces in here. So we have a space before and after the is and after the of, or else it will print out. It will not put these spaces in right there. And I'll show the readout for this here in a moment. And so the other thing you might have noticed I was using is this \n. And that just tells you to go down an extra line. If you put 2 of them, it'll go down an extra 2 lines. So as I said, the writeLine prints out and then goes down to the next line. But if you put these \n's in it, it will go down an extra line. And so if we just pay attention to this first part of the code up here, so when I run that, so we see that the output of 1 was 23. So if I move that there, so that's looking at this, the output of this 0, which is going to output our output 0 here, which was the 1 was, then colon, then this index 1 here, it'll output this output 1 here. And so that's what we see going on right there. Then here we see that I'm concatenating them. So the square of then plus integer is plus integer 2. And so we see that the square of 2, so it's putting in this 2 here, is 4. And so that's the integer 2 here. And then what we see is I have this \n. And so that's skipping this line here. Where up here I did not have the \n. And so it just went down to the next line. We're putting that \n, tells it to go down 2 lines. So it's putting this blank line in right there. And so those are the writeLine methods and sort of the things you can do with the writeLine methods right there. We also have console.write, and so this prints to the console and then does not go down to the next line. So it would print out, like say right here, and if this was write, then the next thing that you print out would actually start after this, but on the same line. Then we see that we have the read line, which we will encounter here in a little bit. And that actually takes in user input. Uh, and with the read line, it takes in the user input on the next line from the previous output, where just console.read takes the input in on the same line as the previous output. Then a few other built-in, actually built-in classes and methods. So the built-in math class here, and you can do different math operations. So math.pow here is taking the power. So with the this here as the base, so the first input as base and the second input as the exponent. We have math.max. So that's just taking the maximum of these two inputs here. So you put a number in for the first one and a number in for the second one, and it will just give you the maximum of the two. And we have square root here, so it just takes the square root of that number. There is also cube root here, so there would actually be an input here, so it just takes the cube root of that. So another interesting one here is this random, and so this creates an object from the built-in random class. So you have to instantiate an object of this random class here, this built-in random class, and then there are these different methods you can use with the object. So our object, which is our random class object dot next, this will output, and I put pseudo in here because technically these are pseudo random, and that's a very technical definition, because like technically it can't be actually random, but it meets some criteria for randomness. So they call it a pseudo random number generator, but for sort of practical purposes we can think of it as just a random number. And so if you do dot next with no arguments here, it will give an integer between 0 and this sort of 2 billion 147 million so on and so forth number here. And that's just because this is the max number for the integer data type, which as we discussed in the data type video is a 32-bit integer. But then you can also do random.next and put a single argument in here, which would just have to be an integer argument, and it will give you a random integer between 0 and num1. Then you can put two arguments in, and it will give you a random number between the first number and the second number. And so here, this is just telling us that it's not inclusive of num2, and that should actually be the case up here as well. So that final number that between the first number and that final number, the final number is not inclusive. So for instance, if we put like a 10 on here, it would be a random number between 0 and 9. So 9 would be the last number it could be. The 10 is not inclusive. Then you can also do next.double or next double, and that gives you a number between 0 and 1. 0 is included, 1 is not included. Next single does the same thing for the floating point number, so 0 inclusive, 1 not inclusive. So another, I guess, built-in class here is this convert, and so you can convert with this built-in method that converts to a 32-bit integer, so the int type here. There is also convert int to int64, which converts it to the long type here. And another method you see quite often is this .toString. So you just take your value here, so this non-string data type, and then do .toString, and it doesn't take any arguments, and it'll turn a number. So if you have like an integer 123, it turns it into the string of 123. And so kind of the important difference here would be that with the integer type 123, you can perform mathematical operations on it, where strings you cannot perform mathematical operations on them. So like if you outputted both of these with a right line, they would both just say 123. But if you turn this into a string and then try to do mathematical operations on it, it would not allow you to do that. All right, so another important thing, so we can use composite methods. So a method can be used in the argument of another method so long as its output type matches the argument parameter for the method it's inside. And so, for instance, if you wanted to find the maximum of more than two numbers, you do math.max, and then you'd take as the first argument math.max of two different numbers, and the second argument the math.max of these two numbers. So the first one is going to output the maximum of num1 and num2. This one will output the maximum of num3 and num4. And so this argument will have as the input the output of this first one. And this input will have as input the output of the second one. So it'll just take the maximum of those two output numbers, then give the maximum of that. You can see you could sort of keep putting in more, so you could do another max or math.max here, and another one here, another one here, and another one here. And so you can get multiple maximum, or you can get maximum for more than two numbers like that. And so if you want to convert a user input, which is default string type, into an integer, so you'd put your console.readline as the argument in the convert.toInt32 here. And you can do the same thing with two methods that you make yourself. So if we have the myAdder here and the myMultiplier here, you could do the myMultiplier taking myAdder with these two arguments as its argument. So the myAdder method will first take 3 plus 7 and output 10. And then so this will have 10 as its input, which then takes this number and multiplies it by 10. So it will give 100 as its output. So we can look at that a little bit here. So we have these classes all activated here. Well, first we'll look at this pseudo random number generator. So I will uncomment that so we can look at that. So I'm instantiating this 4 times. And so you can see that you can do this all on the same line as long as you have these semicolons here. So I have N1, N2, N3, and N4 as random numbers. So I have this rand num here instantiated, and then I'm just getting 4 different random numbers from that same instantiation. So I have 0 and 101 here. So these random numbers will be between 0 and 101 here. And so then this right here will print all those. So N1 equals, then I have this index 0 here, which I'm putting N1 there. Then N2 equals this index 1 here, which will be this, and so on and so forth. So we can run that right here. And so we see this is N1 equals 62, 1, 24, and 9. If we run that again, we get different numbers, 18, 82, 53, 27. You can keep running it and keep getting these different random integers in here. So this was the toString method. So I will uncomment that out. So I have integer n equals 8675309. Then I do string s equals this number up here, then dot toString. So we can also print that out here. So the toString method is just giving us this as a string. We can look at the built-in math methods here. So I'm going to actually be taking the power. So we have the base num and then the power here, and so then it will take in those two numbers, and so these two numbers are going to be input by me using this console.readline and then converted into the int32 right there. So these are using these composite functions here. And so we see that I run this, and so it runs through all this other code, but now it's asking me for a base, and we see that it's asking for it on the same line as the printout here. So I'm doing write dot what base, and we see I'm putting this space here, so it puts a space in there. Then it will take my input, so say I put 5 there, that'll be the base. Now it's asking what power here, so I'm going to input the power, and so I'll do 2 there. And so now it's doing the console.write line. 5 to the power of 2 is 25, and so we have index 0, that's the base num, index 1, that's the power, and then index 2, that is the exponent there, which is taking this math.pow of the base and the power there and giving us the 5 times 5, which is 25. So those are some composite numbers using this math.pow built-in class and method. So I will uncomment this right here. And so we see, so I'm doing int comp num, and then we're just using this multiplier method. So it's taking in this adder method from this instantiation of this class here and taking that as input to this multiplier method. So this method that I wrote here will add 2 numbers and then it will multiply it by this. And since this right here had those static properties. So remember, if we look up here, we have the adder method 3. It's taking these 2 numbers, which if you remember from before, I set equal to 500 and 100. So this will be 500 plus 100. It will output 600. Then the multiplier method will take that and multiply it by 10. And so we should get 6,000 as the output for that. So I'll run the code here, and it's going to ask me for inputs for the base and the power here again. And so I will just put those numbers in as inputs. So we can just put different numbers in here. So I'll do 5, and 5 gives us the 5 to the 5th power. But now we see down here, this composition gives us the 6,000 as I predicted. And so one last thing I wanted to show here, I don't want to get too deep into it because I'm going to talk about this in more detail in later videos, but I just wanted to point out this is something that you can do. So I will uncomment this here and I will uncomment that there. Well, I'll just uncomment it all out of here. And so what we see here, so let's focus most on this rec method here. And so this is just what's called recursion. And so it's essentially a method can call itself. And so we see that this is taking an input here, and then it's actually returning itself with the input plus 1. So if we look at that here, so some things to keep in mind. So a method, as I said, can call itself within the body of the method. So we want to make sure not to have an infinite loop, and so we have to have what's called a bottom to it. And so that is just sort of a last return that is not calling itself. And so this is the example that I'm using here. So we have the recursion class, this rec method. And so this the input, so as long as the input is less than 20, it will call itself with the input plus 1 here. But then once the input is 20 or greater, then it will just return that number. And so we instantiate our class here, so I'll give it the input of 1 here. We want this output here that I'm just calling rec. Then we are using our object calling the method with the input, which is 1. And then so what will happen is the first time it will see that that 1 is less than 20, and so it'll give itself the input up here of input plus 1, which is 1 plus 1 equals 2. So it gives itself 2 as its input. And then it will see that 2 is less than 20. So it gives itself the input plus 1, which is 2 plus 1 equals 3. Again, it sees 3 is less than 20. So it gives itself input plus 1, which is 3 plus 1 equals 4. So on and so forth until it gets to 19 here. 19 is less than 20. So it gives itself 19 plus 1 equals 20. Then the method will determine that 20 is not less than 20. And so it returns 20 without passing the value to itself. And so if we look down here, so I will uncomment this out. And so I'm instantiating the class right here. Then we're getting this rec as our output. I'm just inputting 1 right here. And so it will keep calling itself. And so what I have up here in the method actually, so I have these write lines here. So this will actually just write the input plus the space. So it's just using write here. So it'll all be on the same line. And then so I have this write line here, which will just give us a blank line. And so what we see when I run this code, so again, it's going to ask me for these powers, so I'm just going to put some numbers in there. So what we're looking at here, so it's just printing out the input to the same line each time. That's what this code right here is doing. So we see what the input is. So the first input was 1, but then when it fed this to itself plus 1, the second input was 2, and so it keeps going through all these until it finally gets to the bottom where it's 20. And so this is actually the input, or the print that we have going on right here. So only after it gets to 20 is it actually going to print that out there. So the other recursion I have here, and this is a pretty popular one to use as an example, is actually the Fibonacci number. And I'm not going to go through that too much. So I challenge you to look in the lecture notes at it and try to find out sort of what's going on here. But the thing to notice is we are calling this method, and we are in fact calling it twice in here with -1 and -2. And so what this will actually do is it will take an input here. So we are doing an input, it's converting it to an integer. And so that will actually be the place in the Fibonacci sequence. And then it will actually print out the number, what that number is in the Fibonacci sequence. So for instance, once again, this is going to ask me for these, so we can just do 6 and 6. So now it's asking me for the place in the Fibonacci sequence. And so if I write, for instance, the number 4 here, it'll give me what the Fibonacci number is in the 4th place in the sequence. And so that is 3. And so we could run this again. So just put some random numbers in there. So if I want to know what the number is in the 9th place of the Fibonacci sequence, I put that in, and it tells me that the Fibonacci number is 34. Yeah, so again, like I said, I challenge you to sort of look at this method right here and try to determine like where the bottom of it is and sort of what it's doing. In future videos, I'm going to actually sort of describe what's going on with that when I actually get into recursion. For the purpose of this video, I just wanted to show that recursion is a thing you can do with methods. But anyway, this video is getting a bit long, but just to kind of sum up what we talked about, I talked about the main method, which is the code that's actually going to be run, but within the main method you can call other methods, and so it will run those methods at those places in the main method. We had the static methods, static classes, properties, and methods. So the classes are not instantiated, so the static methods are something where you actually have to use the class name dot method like this to actually use them. Static properties are shared among all instances of the objects instantiated from that class if it is, a non-static class. So yeah, like I said, those numbers will be shared between all instantiations of it. We did have these built-in methods, so this console.writeLine is one that gets used a lot in the console, but we do have like these math ones here we can use. We have random, we have these converting, we have things like toString, and in the videos after this where I talk about like the data structures, we'll run into some more built-in methods that you can use for those data structures. I talked about composite methods where we can use methods in the arguments of other methods so long as the output of those methods is the correct input for that parameter of the method into which it is the argument. And then I briefly introduced us to this idea of recursion. And we also talked about these constructors here. So these constructors where we just take the method but with these arguments here that are then sort of put into the method like this with the different number and different types of arguments. But anyway, I hope you found this somewhat long video helpful, and I will see you in the next one.